Namaskar. I am so happy to do today's YouTube video. Sometimes you may be thinking it may be the reason that today I am going to do 239th video. It may be its reason. Sometimes you may be thinking like that. But actually it wasn't. Today I start a new series. Its first episode is 239th video. This series name is Accidental Inventions English Episode 1. What is the meaning of accidental inventions? You know, most of the inventions have happened accidentally. If Röntgen has invented X-ray, it was also an accidental invention. He wasn't trying to invent X-rays. He was in his experimental workshop for experimenting some other things. He was trying to invent some other thing. In between, some rays crossed his hands. He feared and he removed his hands from there. He just listened. His hands photo, not the photo of his flesh, photo of bones and that kind of hard things photo he could see. Unfortunately, in between his experiments, he invented X-rays. Inventions happen accidentally. Some of the incidents happen accidentally. And when compared with this kind of inventors, this kind of scientists. Now I told about Röntgen who invented X-rays. If I say about Edison, he had invented nearly 2,500 good things. He has the patent of nearly 2,500 invented things. But most of the inventors weren't able and expert, or they weren't brilliant when they were so young. Especially in their childhood, they weren't expert. They weren't brilliant. Once, when Edison was so small boy, he could see one hen is sitting on the eggs for giving birth to its new kids. He watched it so curiously and he was doing his first invention. Now I told the word invention, but if I was writing that word in letters, I would have put apostrophe above the invention, because what was he inventing in his childhood? He saw hen is sitting on the eggs for giving birth to new kids. He too brought some eggs and he started to sit on those eggs for giving birth to new kids. His mother saw it and she scolded him. That is the childhood one incident of Edison. When compared with the childhood activities of some scientists or the fearful atmosphere of these scientists, it means Röntgen also feared when X-rays crossed his hands. It was an accidental invention. So, when we compare with these kind of so many inventions, most of the inventions happen accidentally. I too have got some accidents. It was road accidents. But I don't like to say about those road accidents now. I would like to say about some accidental inventions. I too didn't think I may reach in invention. I haven't invented anything like Röntgen, Edison, Newton or some other great inventors. But my journey from fabrication to fabrication, so many calculations I had to do, so many developments I had to do, so many trigonometrical scientific calculations I had to do. I had taken a lot of time for those calculations. So, in between some calculations, I have thought, will there be a relationship with this value and the value of the origin? I will explain it when this video reaches in its ultimate stage. We shall go to the matter. I am so interested in fabrication, especially its developments. You know what is development. In so many videos, I have told you and I have taught you what is invention. If you make a cone, or if you make a square to round job, or if you make some other rolled jobs or bent jobs, before it is rolled or before it is bent, it was in a plain sheet. It was in a plain place as a plain sheet or plain plate. It will be cut in different lengths, widths or different shapes. This shape, before it is being bent or before it is being rolled, there will be a shape. There will be a structure. This shape is called development. If we have to make a cone, before making cone, before bending, before rolling, it will have a shape. In that shape we will mark and we will cut and we will be ready for its rolling. Before rolling or before bending, it will have a structure, one shape. This shape is called development. Especially, I had to make these kind of pipes so many times. It is the approximate structure of a pipe which is going through 90-degree bend. If we have to make this kind of one pipe in 90 degree, one pipe can be used and it has to get this kind of profile cutting. When I did this sketch, it is not in a straight line because I was using hand sketches only. I didn't use scale or compass or protractor. You have to use scale, protractor, set square, compass and everything for writing these sketches to your notebook because you are studying only. Now I am teaching you with this kind of freehand sketches. And one thing more I would like to remind you now. When you will be studying my classes, you have to be with one notebook and pen and instrument box. Because you are not seeing a cinema. You are not seeing a video. You have to remember about it. So, please take one notebook, one pen and instrument box and see this video. Otherwise, it won't have a result for you. Okay. If we have to make this kind of one pipe can be cut in different lengths. This length and the next part's length, this length and this length, all lengths are different. If we cut this kind of pipes, different types of measurements have to be added here. It is lengthiest side, it doesn't have more length also. It is the shortest side of this pipe. So, we can cut one pipe and we can make like this, or we can roll or bend one plain sheet or plain plate and we can make like this also. Both times we need calculations, trigonometrical calculations. I have just drawn the picture of only this pipe here. This pipe I have drawn here. It isn't a plain sheet or plain plate. Remember, it is a pipe. We have to make this kind of one pipe. For that purpose, what we have to do? We have to divide this circle. Its bottom is circle, its top is circle, in between every portion is circle, but it is the view of elevation, front view. So, we are seeing in this form. If we look from top side, we will see like a round shaped job. So, once again I have written it here. This is the elevation of this pipe. What is elevation? Elevation is the front view of a job. And its top view, when we look from top side, that is called plan. This is plan. It is the view from top. When we look it from here, we see its front side, that is this side. Okay. If we have to make its development, we have to divide this circle. It is round shaped job like this. We have to divide it with 12 equal parts. If it is bigger than this pipe, 12 may not be enough for you. If you think 12 is not giving accuracy to you, then you have to divide it with 16 or 20 or 24 or bigger than these all numbers. If it is a small pipe, there is no need for you to divide it with 12 also. You can use 8 divisions or 4 divisions also. That is according to the diameter of pipe. If it is bigger, there should be more divisions for accuracy. Now, I divide it with 12 parts. Most of the time, I have got to divide it with 12 parts. Then I had to undergo a lot of calculations. Now, we are going to make this kind of one job. Its measurement, for example, we can think its length is top side, lengthiest side is 1234 and its diameter is 400. And this pipe gets bent in 90 degree. If it is 90 degree bent, these two cuttings will be in 45 degree. From here to here, there will be 45 degree, and here to here also there will be 45 degree. 45 plus 45, 90 degree. 90 degree it is going. Okay. So we shall make in this measurement one pipe. For making this pipe, we have to divide it with the 12 equal parts. 0 to 1 is a one part, and 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Then it is 6 parts. It is the half portion. This half portion has to be added in here also. Then another half portion will come. Half portion plus half portion. One full roundup will be developed. I have used hand sketches, so in between gaps are not equal. But if you draw this circle with the proper compass and proper scale and everything, 0 to 1 and 1 to 2 and these all measurements will be in equal distance in plan. But this distance, 0 to 1 distance, is visible in elevation that is not equal when compared with 0 to 1 and 1 to 2. 1 to 2 will be bigger than 0 to 1. And this one is more bigger than this one and this one also. And another one thing, this 0 to 1, this 0 to 1, and this 6 to 5. Here to here is 6 to 5. These two widths will be same, and widths from here to here, it means 5 to 4 and 1 to 2 will be same. This 0 is the point in round shape which is visible in plan. This 0 starts from here and it reaches up to the bottom of this pipe. So from here to here is 0. Here to here is 6. But in elevation, 6 is visible from here to here, but it is top view. So in top view, we can see 6 in one point. We can see 5 in one point only, but here it is visible in one full line. This full line, 5 is one more time comes in its another side. It is half portion only, visible area is half portion. It's another half portion is there. So from here to here is the line of 5. Like that, one line will be in its far side also. One line is here and another line is here. When we look from here, we see this 5's line only. That is this line. But if we look from top side, we can see the 2 points of 5. This is 1 point of 5. This is another point of 5. This is 1 point of 4. This is another point of 4. But in elevation, we can see full length 4. From here to here is 4. But opposite side 4 isn't visible here. But you have to think another 1 4 is there opposite side of this elevation. Okay. So first of all, we have to, for making its development, this length is this length differs from the length of 5, the length of 4, the length of 3, the length of 2, the length of 1, and the length of 0. When it reaches in 0, we get shortest length. This is the lengthiest side, and all lengths are different. And this gap is also different in different area, in elevation. But in plan, this measurement is visible as true length. This is exact length. So we can call this length from 0 to 1 in curved portion is true length. But this 0 to 1 is visible. This is 0 line. This is 1 line of 1. These two from here to here is the true length, and it is non-true length because it is visible from this side only. If we look from this side, the points comes in this area, approximate center area will be visible as a straight line, approximate straight line. So this much of area will be visible as approximate this much. This much of curved area will be visible as approximate that much. But here curved area is there. But when we look from top side, we see true length. But when we look from here, our seeing from here, when we look from here, it will have a curved area. We see more curved area. From here, we look to the center, we see most of the plain area. When we look very near to 0, 4, 1 area, we see not approximate straight area and more curved area. So from here to here is only a little length. And here to here is too much big. This length and this length is same. When I drew it with my hands, this length has got some more width, but it isn't actual truth. When you do it in your notebook, you have to use proper divisions and proper straight lines have to be drawn. Then from here to here, 3 to 2 will be equal to this 3 to 4. And this 1 to 2 will be equal to this 5 to 6. Okay. We have to make this kind of one job. Its first length 6 has to be 6. Already we have that measurement 1234. And this 5, this is the line of 5. We have to find out it. How will we find out it? If we have to find out this 5, first of all, we have to get this measurement. If we get this measurement with this measurement and this degree, you know this degree is 45 degree. First we have told about it. This triangle I have just drawn here also. This line is this line, and from here to here one line is there, that is this line, and from here to there one line is there, that is this line. If we get this line, we have to get this line, that is our aim. If we get this line, with this line and this degree, with this line and this degree, 45 degree, we can find out this length, means this length we can find out from here to here, how much is coming, that we can find out. If we find out with this length, from 1234, if we decrease this length, we will get the length of 5 from here to here. Like that, all measurements we have to find out. 4 we have to find out, 3 line we have to find out, 2, 1 finally we have to find out 0. It has to be found out twice. Means If we have found out 1, it can be used for its opposite side also. If we have found out the measurement of 2, it can be used for this 2 also. If we have found out the measurement of 3, it can be used for 3. Which is in opposite side. Okay. For finding out this measurement, I had to undergo so many calculations. Once again, I have drawn those pictures here. In this picture, just listen. How will we be finding out the measurement from 5 to 6? This 5 to 6 is true length. We know this measurement how much will be. But we have to find out non-true length. This point is 5. This point is 6. This is non-true length. This point is 5. This point is 6. This non-true length we have to find out. Then only we will get the distance measurement from this corner to this point. This point means 5 line ends here. From this line, if we draw a perpendicular to this line, it reaches here. This measurement we have to get. Then we can decrease this measurement from this total length 1234. Okay, if we shall start that measurement. We shall start to find out this measurement 5 to 6. When we may find out this 5 to 6, already we will get the measurement of 0 to 1 also, because 0 to 1 and 5 to 6 are same measurement, I have told you. And 1 to 2 and 4 to 5 both are same measurement. And 2 to 3 and 3 to 4 both are same measurement. Okay, we shall find out the non-true length of 5 to 6. How will we be finding out? We can make a triangle using the using the points A, 6, 5. We can make one triangle A, 6, 5 using A to 6 I have drawn here, A to 6, 6 to 5 I have drawn here, 6 to 5, 5 to A I have drawn here. It is a triangle, but there isn't a 90 degree in this one, because from A to 6 one perpendicular line we haven't drawn, or 5 to top side we haven't drawn one perpendicular line. We have to make one perpendicular line. In this triangle there should be a 90 degree. That has to be with us for doing trigonometrical calculations. Why did we draw this kind of triangle? If we make a line from here to top side, which will be perpendicular to the point line 6A, that has been drawn here. A to 6 I have drawn here, A to 6. 6 to 5 I have drawn here, this 6 to 5. And 5 to A I have drawn here, this 5 to A. And this 5 reaches in B. Then it becomes 90 degree. If we find out the measurement of A to B, already we will get this measurement 6 to B, because everybody knows this A to 5 is 200, because in last page we have told our diameter is 400. If diameter is 400 from here to here, its half is radius from here to here is 200. So this length here to here is 200. Here to here is 200. Here to here is 200. All measurements from center to the outer line of round is 200. Here to here is 200. And here to here is 200. A to 5 is 200. A to 5 is 200. A to 6 is also 200. A to 6 is also 200. Those measurements I have written here. A to 5 is 200. A to 6 is also 200. If we get the measurement from B to A, already we will get the measurement of 6 to B, because 6 to A is 200. 200 minus this B to A will be the measurement from 6 to B. So we will get this measurement. 6 to B means the measurement from here to here. One point comes here, that is B. 6 to B means from here to here. This B is reaching in the center of this line. Okay, this is B. This is B. From here to here is 6 to B. Or another way we can say 6 to 5. If we get the measurement of 6 to B, we will get the measurement of 6 to A. Both are same. Okay, we can find out 6 to B. If we have to find out 6 to B, we have to use trigonometrical calculations. I have taught you so many trigonometrical calculations. For that purpose, we have to use sine theta, cos theta, tan theta. I have told you and I have taught you so many times. Sine theta is opposite side divided by hypotenuse. Opposite side divided by hypotenuse, and cos theta is adjacent side divided by hypotenuse, and tan theta is opposite side divided by adjacent side. Remember, we have divided this circle into 12 parts. 12. 1, 2, 3, 4, 5, 6. Then again, 7th portion is 5. And 8th portion is 4. And the 9th portion is 3. And the 10th 10th portion is 2, and 11th portion is 1, and the 10th portion is again 0. So, for making one circle, one line has to start from here, that, and we have to draw one round making 360 degrees. 360 degree reaches in 6 to A again. We start one round from pointing A to 6, and this line, from this line we start our round, and it has to have a degree of 360, then again it reaches in 6. Two lines are matching in 1 degree. That is 360 degree. So, this 360 degree is divided with 12. 1 part's degree will be formed. How much it will be? What is the degree of 360 divided by 12? That will be 30 degree. This is 30 degree. This is 30 degree. This is 30 degree. I have written here 30 degree. This kind of 12 30 degrees will be forming, then one round full will be formed. Okay. Those all I have described in my earlier another videos. So, we shall come to the trigonometrical calculations. In these 3 formulas, which formula we can use? Cos theta can be used. If we use cos theta, we will have the measurement of cos theta, that is 30 degree, cos 30 degree, and adjacent side we don't have. Here to here is adjacent side. We have to get it, so we have to write just adjacent side only. Divided by hypotenuse we have. What is hypotenuse? This is hypotenuse. From here to here is hypotenuse. That we have. Okay. So, we shall use the formula cos theta is equal to adjacent side divided by hypotenuse. In this cos theta, theta is cos 30, and adjacent side we don't have, we have to write it here. And hypotenuse 200. From here to here is 200. I don't describe those all in this episode because I have described those all in my another series. I have engineering related so many series are there. You know everything, you are seeing it also. One is fabricated cones. It's a Malayalam version is there, English version is there, Hindi version is there. Another one fabrication related subject is Malayalam toolbox talk. Its English version is there, Hindi version is also there. And another one fabrication engineering related subject is fabrication doubt clearing session. It's Malayalam version is there, English version is there, Hindi version is there. And another one I have just started from today onwards. Its name is Accidental Inventions. Its Malayalam version is there, it is English version, and Hindi version is also will be done tomorrow. Okay. So you have to check my earlier fabrication related videos. Then in those videos I have described about these calculations. Okay, cos 30 is equal to adjacent side root by hypotenuse. Hypotenuse 200. We have to get adjacent side only. So we have to keep adjacent side here, and we have to take this 200 to the left side of this is equal to. If it is in bottom side, when it reaches in the left side of this calculation, it will be in top side. If it has been divided here, when it reaches in top side, it will be multiplied. It has happened here. We kept adjacent side here, and we have taken 200 to here. Then it reached in top side, and it has been multiplied. Then just calculate cos 30 into 200 in your calculator. Then you will get, it will be 173.21. Okay. So what is this 173.21? Measurement from here to here is 173.21. As I have told you, from measurement from here to 6 is 200. If it is so, what will be the measurement from here to here? We have to decrease 200 from, we have to decrease 173.2 from 200. 200 minus 173.21 is 26.8. Then we go to this measurement. It was our aim. If we have got this 26.8, with this measurement 26.8, this is 26.8, and this degree is 45 degree. With this degree and this measurement, we will get this vertical length. Then we can find out the measurement of 5. We can find out the length of 5. Then we can find out the length of 4. We can find out all lines. We can find out. So, for finding out this 5, 4, 3, 2, 1 and 0, first of all we have to find out this measurement. How much of calculations we have done? It is very difficult for me. I had to do so many this kind of pipes every day, and every hour I had to do the developments of this kind of so many pipes. So I thought there will be a relationship with this measurement and its radius. Means if this measurement increases, this radius also may be increased. I thought like that. And if this measurement comes down, this radius also may be coming down. I just thought, and I just checked this measurement in so many circles. So I thought, how many times big will be this radius when compared with this 26.8 measurement? Means 6 to B or 6 to 5 measurement. For that purpose, I just divided to 200 with this measurement is 200. From here to here is 200. I divided this 200 with the smallest number 26.8. Then I could find out this 26.7949 is 7.4641 times bigger. Sorry, this 200 is 7.4641 times bigger than this 26.7949. I checked this kind of measurements in so many triangles. Everywhere I could find out this constant 7.4641. This 26.8's 7.4641 times big is this 200. So, why should we do these all calculations? I thought this kind of one formula has to be avoided, has to be used, because radius for finding out 6 to b or finding out 6 to 5, for finding out 6 to b or finding out 6 to b, we have to use the formula radius divided by 7.4641. If this radius 200 is divided with 7.4641, we get this 26.8, we get this 6 to b, we get this 6 to 5. So I could accidentally, once again I repeat the word, accidentally invent 6 to b is radius divided by 7.4641. Radius divided by 7.4641. It was my first invention. Okay. It happened accidentally. Most of the accidents are happening accidentally. So, why did I invent it? Why could I invent it? Actually, I didn't invent it for inventing. Accidentally, I invented it. Why did I invent it? I invented it for my easy work. It for my speedy work. I have to do this calculation very easily. I was trying to find out different methods. Finally, I could reach in this formula. So, we will say always as a proverb, necessity is the mother of inventions. Here, it happened actually. It was my necessity. This speedy work was my necessity. So, I could invent this formula. So, necessity is the mother of inventions. Speed, for getting speed in our life, we will find out some things. So, speed is the mother of invention, and easiness is the mother of getting easiness to life. And for all kind of works, we try our best. So, easiness is the mother of inventions. Necessity is the mother of inventions. Speed is the mother of inventions. Our life has to be happiness. For making happiness, we invent. I invented this one. Remember it. Please note this. I invented accidentally. So, we could find out the measurement 5 very easily. In its opposite side also 1.5 comes. That has also been invented very easily. When we invented this measurement from here to here, already we got the measurement from here to here also. So we can very easily find out this measurement. When we find out this measurement, already its opposite side measurement line of 1 also will be found out very easily. Okay. Now we got it. Now we have to find out 5. How will we be finding out the length from here to here? 5. That is the line. Sorry, we found out 5. In between 5 to 6, we found out. We have to get measurement. Get the measurement of 4. If we have to get the measurement of 4, we have to get the measurement of 4 to 5 or 4 to 6 or 4 to 3. In this 3, one measurement we have to get. So, for finding out this measurement, we used this kind of one triangle and calculated. We can make another triangle pointing not 6 to 5, pointing 6 to 4. Because we have to get the measurement of 4. 6 to 4, I have written it here, 6 to 4. And 4 to A, I have written it here, 4 to A. And A to 6, I have written it here, A to 6. Using this A, 6, 4 points, we made a triangle that is here. Earlier we have done one perpendicular line from 5 to B. Like that, one perpendicular line we have to make from point of 4. It has to reach in A6 line, 6 to A line. Then it will reach in C. We know this 200. There is no need for me to say it again because you are engineers or you are fabrication supervisors or you are skilled fabricators. Okay. So I don't describe more all, and these all have been described in my earlier another videos. So I don't repeat it. Okay. This measurement is 200. Then I ask you what will be this degree. Earlier this degree was 30 degree. 6 to 5, 1 degree is 30. Now we are making a triangle from 6A and 4. What will be the angle 6A4? Everybody knows. If 6A5 is 30 degree, another 30 degree is coming 5 in between 5A4. Now these two degrees will be added, then 6A4 will be 60 degree. So 6A4 will be 60 degree. This is 60 degree. I have written it in next page. 6A4 degrees 60 degree, and this measurement is 200. I have told A4 6 in last page. Okay. So we have to find out the length from A to C. If we find out the length from A to C, what will happen? We can very easily find out C to 6 also, because from 6 to A is 200. 200 minus C to A. So we shall find out C to A. For that purpose also we have to use trigonometrical calculations. Cos theta, again we can use the adjacent side divided by hypotenuse. In cos theta is 60 degree, and adjacent side we don't have, we have written it, we have to write it like that. Adjacent, yes. And hypotenuse is 200. Hypotenuse 200 we have written it. We have to find out adjacent side. So we have to keep adjacent side in the right side of this is equal to, and 200 has to be taken to left side. If it is in downside, when it reaches in top side, it has reached in top side. And if it has been divided, when it reaches in left side of is equal to, it will be multiplied. Both has happened here. Cos 60 into 200 is adjacent side. Just make one calculation in your calculator. Then cos 60 into 200 will be 100. This measurement C to A is 100. Then I could realize one thing. Why should I make these all calculations? I thought it ends in 0, so we can very easily find out 100 is 2 times lesser than 200. And 200 is double of 100. So I checked this measurement in so many circles. I used so many circles. I made so many circles, not 200, another so many circles I have used, 234, 354, like that, so many circles I have drawn, and I just checked everywhere. I could find out C to A, that means 4 to 3, not this 4 to 3, it is true length, but this is the true length, this is non-true length. This is non-true length. From here to here is non-true length. That I could find out this C to A is the real half of radius. C to A, this is C to A or C to 6, both are same. C to 6. C to 6 and C to A both are same, because this is 100. If it is so, this also will be 100, because total length is 200. Okay. So in this triangle using A4C triangle, using this 60 degree and this 200, using this formula, we could find out 100. Total length is 200. So, if it is 100, this one also will be 100. C26 is also will be 100. C26 is also 200. C26, in another way we can say 426. It is non-true length. Actual length of 4 to 6 is this. 4 to 6 curved length is actual true length. This is not true length, it is non-true length. But we have to find out non-true length. Then only, if we have found out this 400, using this 100 and this degree, 45 degree. In last page I have told you 45 degree. This 4 degree and 100, we can find out this length. If we find out this length, from this total length, if we decrease only this length, we have found out this length, we will get the length of 4 from here to here. If we have got the length of 4 to 4, already we will get the length of its opposite side 4 also. If this is 100, this one also will be 100. So, I checked this 100 and 200 relationship. We can very easily, we can say 200 is double of 100 because 0 ends in this one. But if it wasn't ending in 0, we wouldn't have told like that. But so I checked in so many triangles everywhere. 200 divided by 100 is equal to 2. Radius divided by this measurement C26 is multiplied with 2, we get radius. Everywhere I could find out. So C2A is radius divided by 2. Radius is divided with the 2, then we will get C2A. Another way we can say C26, both are same. C2A and C26 both are same measurement. Now we found out both are 100 and C2, instead of C26 we can say 4 to 6 also, because this is the line of 4. From here to here is a line, dashed line, that is the line of 4. 4 to 6 is also radius by 2. C to 6 is also radius by 2. A to C is also radius by 2. 3 to 4 is also radius by 2. So, unexpected time, accidentally I was inventing one more formula. So, remember this formula, C to A. C means this measurement and A means this measurement. C to A is radius by 2. Radius by 2. This is my second invention. Now I told you about 2 accidental inventions. In another episodes, I will describe about another formulas I have invented. Not I didn't invent anything. Everything was for speedy works. Everything was for my necessity. Everything was for easiness. So, you watched this video and you are also in the field of inventions. We shall be with inventions. We should be able and expert in our own fields. So I just conclude this one. Thank you very much for watching. We shall meet in next episode, Excellent Inventions English episode 2. Up to that time, I say goodbye to you. Be with good trigonometrical calculators. Do good fabrication works safely, accurately, finishingly and speedily. Okay, thank you very much.